Okay, this next video is going to still be using the inverse norm um, part of the calculator, but we're going to actually focus on something I refer to as the serial scenario. And the reason I say that is because you're going to see this scenario pop up several more times. So a packing machine is set to fill a cardboard box with a mean of 16.2 ounces of cereal. I'll write that down. I know that's important. Suppose the amounts per box form a normal distribution. That's important because if it's the normal distribution, I can be using either a norm CDF or an inverse norm. Remember, if they ask for the app, I use norm CDF. If they give me an area percent or probability, if they give me the app, I use the inverse norm with a standard deviation of 0.1. What percentage of the boxes will end up with at least 1 pound of cereal? First off, this is a little bit tricky because this is asking for 1 pound. This is in ounces. We need to know that a pound is 16 ounces. All right, because everything else is in ounces, so we converted that to ounces. That'll help us out. Now they asked for a percentage. So since they said what percentage, since they asked for the app, this means I have to use the norm CDF. All right, so this is going to be a norm CDF. So we want the probability that X is greater than 16 because it says more than 1 pound. Now I just make a habit every time they say normal and they're asking for a percentage, I generally sit there and I just write this down. So in this case, we want the probability that Z is greater than 16 minus 16.2 over 0.1. If I'm drawing my picture of this, which I probably should have already done, this is at 16.2 because that's my mean. I know that 16 is below it. And they say at least, so I'm looking for this area up here. And I can go that, hey, that's over halfway, so my area should be greater than halfway. So let's go ahead and run this thing. All right, so second vars, normal, CDF. My lower part of my shading is 16. The upper part is 99999. My mean was 16.2, and my standard deviation is 0.1. And we end up getting 0.9772 as our answer. So about 97% of the boxes will have 16 ounces. Now, if you think about when you buy cereal at the store, generally speaking, they say, oh, the box weighs 1 pound. Well, they may be setting their machine at 16.2 ounces, because if it's set at exactly 16, about half will get too much and half will get too little. Here we know 97% of the people are getting at least what they paid for. There's about a little over 2%, almost 3, or a little over 2% are not getting everything they paid for. All right, the next thing. 10% of the boxes will contain what number of ounces? Well, this time they gave me an app. And if they give me an app, then I need to use the inverse norm. Now, they didn't tell me this was a percentile rank. So since they didn't tell me it was a percentile rank, I need to draw my little X. 10% will contain less. Oh, less is below. Hey, that's good news. That means I'm starting off at negative infinity. Because remember, the normal curve is going from negative infinity to positive infinity. We have a mean right here of 16.2. And now that I know that this started off on the low side, it started at negative infinity. And anytime we have the net go to negative infinity, we don't have to subtract. All right, so I'm not going to have to subtract on this one. So this is going to be inverse norm. And my area is 0.10. My mean is 16.2. and my standard deviation is 0.1. Second vars, inverse norm, area 0.1, mean 16.2, standard deviation 0.1. And I end up getting 16.0718. Oops. So try writing actually what it says on the calculator, 16.0718. Now, so that means this value right here, 16.07, that's less than 16.2. It makes sense that it's less because we have it on the number line and it's less there. 80% of the boxes will contain more than what number of ounces? Well, once again, they don't tell me that 80%, whether that 80% is a percentile rank. So they don't tell me, I need to make an X. 80% will contain more, so more would be above. So the 80% is above. All right. Now they gave me a percent. Anytime they give you an app, you know you're working with inverse norm. So anytime they give you an area, percent, or probability. So let's draw our picture. So we know our mean is 79. This is negative infinity, and this is positive infinity. Well, this is on the upper side, so consequently, we know we're shading from the right, and because it's 80%, it's over halfway. So this is over halfway. So this part right here, we're going to be below. Well, keep in mind, even though we have 80%, the calculator works from left to right. The calculator works from left to right. So this is going to be 1 minus 0.8. So we're actually going to have to plug in 20% into the calculator. So inverse norm, 0.2, mean of 79, or excuse me, I'm sorry, that's from the previous problem. Mean of 16.2, standard deviation of 0.1. So second vars, inverse norm, area in this case, 0.2 because we had to subtract, or if you wanted to, you could have just done 1 minus the 0.8. And we end up getting 16.1158. All right, next one. 90% of the boxes will be below what weight? All right, so once again, they didn't tell me whether or not I'm working with they don't say percentile rank. So 90% of the boxes will be below. So I draw my X and I go, oh, this is 0.90. So that means I'm starting from the left. Once again, my mean is 79. We're starting from negative infinity to the positive infinity. And so 90% means I'm going from here, and this is 50%, so I'm going to have to cross. So we know we're shading all the way up. The good news is we started at negative infinity, so we don't have to subtract. Also, they gave us an app. If they give you an area, percent, or probability, you have to use inverse norm. So this is going to be inverse norm. And we're going to go area is 0.9, mean is 79, standard deviation in this particular case. Gosh, I keep doing that. I'm so sorry. Mean is 16.2, standard deviation is 0.1. Standard deviation is 0.1. Second vars, inverse norm. We didn't have to subtract 0.9. We end up getting 16.32. Does that make sense? Does that make sense? And it's like, well, 16.32 is above 16.2. So yeah, that does make sense. 16.3281 was the value I got on the calculator. And by the way, this one also should have been centered at 16.2. Okay? The next one, 70% of the boxes are above what weight? They did not say percentile rank, so I need to use my little trick. I'll draw an X, 70% are above. Oh, so this is above. Great. That means we're shading from the right, so we know the direction we're coming from. Make sure I have the correct mean this time of 16.2. We're going positive infinity to negative infinity. This time we're above, so we're shading from the right. 70% is over halfway, so I'm going to have to cross the mean. This area is 0.70. Now, please think about this for just a moment. They gave you, if they give you an area, percent, or probability, if they give you an app, you use inverse norm. They did. They gave us a percent, so we're going to have to use inverse norm. But we have to be careful here, because remember, if it's shading from the right, we have to subtract. So 1 minus 0.70 is 0.30. So this little area right here is the part that we're looking for, this 0.30. So consequently, I'm expecting my X value to be less than 16.2 because it's below 16.2. So inverse norm of 0.30, mean of 16.2, standard deviation of 0.1. Second vars, inverse norm. Area is 0.30, 16.2, and we end up getting 16.1475. 16.1475. And 16.1 is definitely less than 16.2, so we know that we're probably in the right area. Last problem for this serial scenario that we're going to work with today. 15% of the boxes are above what weight? Doesn't say percentile rank, so I need to use my little X trick. So my X trick is this. I put my X, 15% are above, so that means 0.15 is above. So I'm going to draw my picture. And this is going to be 16.2. Because it's above, we know we're shading from the right. So this is going to be 0.15. So my X is going to be here. So I'm going to expect a value that's greater than 16.2 because we're above 16.2. So we're expecting an area greater than that. Now remember, the calculator works from left to right. So if we don't have negative infinity, we're going to have to subtract to find that area. So this is going to be 1 minus 0.15, which is 0.85. And it makes sense that our area is larger, that our area is this big, because we cross the mean. So this is 50% plus some more, all right? Now this is going to be an inverse norm, and I know it's an inverse norm because they gave me an app. They gave me a percent, so that's what I need to use. So this is going to be 0.85, mean of 16.2, standard deviation of 0.1. Second vars, inverse norm, area 0.85, mean of 16.2, standard deviation of 0.1. And we're going to get 16.3036. All right? Now, does that answer make sense before we write it down? It's like 16.3 is definitely bigger than 16.2. Makes some sense. So I'm going to go ahead and write that down. And that's what my X is. All right? So remember, if they give you an area percent or probability, you use inverse norm. If they ask for it, you use norm CDF. If they give you a percent, it really helps to use the little X trick to determine whether you're shading from positive infinity or shading from negative infinity. If you're shading from positive infinity, you have to do 1 minus. Okay, thank you. And next video will be on centered about the mean.